So who am I? I've done a few projects that you might have heard of. The current project is Weave, which is the company's called Weaveworks. I also founded RabbitMQ and Cohesive and some other things that are not shown. And for a while I was put in charge of Spring as the product manager and made some new things which you might have heard of, like Spring Boot and Spring Cloud and other cool stuff. So today's question is, can I go faster with technology? Now, you probably all know what the answer is. I've just put it there. Yes, you can. But I'm going to be talking about something called cloud native, which is, of course, a buzzword. But it's a good buzzword. And I'll be talking about a few things in relation to that. The economics of convenience, which is something that I think Amazon have really introduced, at least for software. The war of the platforms, what's at stake there, a little bit of that. And a little bit about what's missing, which is, of course, my opportunity to talk about myself. So it's become a standard in the current cycle to talk about unicorns and big web companies as a sort of paradigm for how you can build more software more quickly and do more well and make more money and be more famous. And if you're Adrian, you can talk a lot about Netflix all around the world and then get a fantastic job at Battery to do the same thing, which is just great. But for the rest of us, we're kind of wondering, what do we need to do in order to be like these companies, to kind of build technology really quickly and then scale it up to large size? I mean, this really matters because now software is critical to business. You know, if you're a hotel company, Intercontinental, Marriott, you're worried about Airbnb. They really are a threat to your business. And what's particularly noticeable if you look at these companies is most of them are new. They are founded fairly recently. In the last 15 years. These really big technology companies didn't start in the 90s, a few of them did, but many, many more started more recently. And that's because they've been able to move quickly, that they've been able to grow so big so fast. And that is, you know, the so-called unicorn, the billion-dollar company. So can anyone become a unicorn? If I'm running a little startup down here in Shoreditch, what do I need to do to become more like one of these fantastically brilliant Silicon Valley companies? Should I just move to Silicon Valley? We have a lot of talent here in Europe and in the UK. We are plucky, we are resilient, and we can do it.
Don't tell him your name, Richardson.
And all we need to do is move to the roundabout just over there, and everything will be amazing. Actually, there are no unicorns on this picture, although I believe there are 7 in the UK, companies like Asos, for example. So what are the ingredients for success? Well, you do definitely need money to actually build software. I mean, there's no question that doing it without any money, and I speak here as someone who started several open source companies, is tricky. Then you need developers. Developers are really, really important. We've got to the point now where if a developer refuses to do something for a business, it can be mission critical. You know, if you've got your business and you're chasing Airbnb and your hotel company, you've got this great new team that's got this kind of room sharing thing going on, and suddenly the lead developer is sick or has just taken a job at Netflix, you know, you're stuffed. So you've got to have a big, strong, adept development team. It's not enough just to have a few people and do things in the old way. These guys are critical guys and gals. And you've got to have the right technology, which is what we'll be talking about a little bit today. So that surely is the mix. Money, developers, technology. And then, hey presto, everyone can do it. So the phrase or the word, the expression that people have been using recently to describe this correct mix of technologies and people and practices, and of course money, is cloud native. Meaning not it runs in the cloud, but it is architected according to a set of practices that means that it looks like the applications that people do run, have built on Amazon and also run in-house. The Netflix style architecture, for example. And it's these agile practices like continuous integration and continuous deployment. So enabling rapid change, breaking things up into small pieces, microservices. I'm preaching to the choir in this, I know. That is all adding up to cloud native, which is of course a buzzword. So, here's my attempt to do a buzzword bingo card for cloud, but feel free to hack this later. You may have heard some of these expressions today. If you don't, demand your money back. But what it's really about is economics. What I think of as the economics of convenience. It's easy for me to do whatever I like with the cloud. That's the point. That's what Amazon's innovation was, and why it took everyone else so long to realize what the hell they were doing. All these big hosting companies saying, but we do hosting too. That's not the point. The point is making it so easy for somebody to start and stop, to scale up, to scale down, and so much more. And what people have done, and what Cloud Native is all about, is taking this idea and applying it to as much of the stack as you can. Which brings us to this. Who's heard of Docker? Has anyone not put their hand up? See me later. So what Docker does is it exemplifies convenience. It's not about containers, it's about convenience. It's about giving an API to this thing called a container that makes it easy for developers to do things with it. Hence, millions of users a month, downloading it. They're claiming, I think, 800 million downloads now, whatever that means. But it's a lot. Now, it clearly is a lot. This is a change. It's very important. And the next change that's coming is this shift not just from one technology to several, to containers as a container-centric approach to architecture, and to a microservices agile enabling philosophy in multiple different facets of the architecture, and to a lot more automation. You'll notice I'm using these hedging words all the time. A bit of this, a bit of that, a bias towards the other thing. That's because the reality is that when people do cloud native, it's not 100% containers, it's not 100% microservices, it's not 100% cloud, it's not 100% automated. But you're using more and more and more of this technology. And it's like the web in the 90s, which initially was just a way to put, a kind of the address of your business onto, the internet so that people could find you and maybe phone you. But now what they're doing is that people are introducing these technologies to build apps and services. So we're seeing a revolution equivalent to the 90s for websites, but for applications and services. And as I mentioned earlier, these are business critical. If you don't have a software development team in your business that understands this and can build digital experiences for your customers, you will lose out to people who just spend all their time doing that, like Airbnb, as I mentioned. So I've been spending a lot of my time in the last few weeks trying to kind of come up with a way of describing the stack for cloud native architectures. Now, one of the paradoxes here is if you go talk to all these companies, none of them are using the same technology exactly. So it's not the case that there is currently a standard toolkit for this, but there are patterns, and as more time goes by, you can recognize clear demarcations of role and function. And I think that we're starting to sort of see the wood for the trees now, and it's possible to talk about a 3-layer stack with a little bit of hand waving. And the layers are automated infrastructure, a container service, and domain-specific tools. And obviously the bit in the middle is new and didn't really exist a few years ago. In 2006, Amazon started all this off with EC2, which is the first piece of automated infrastructure. That layer has evolved now. You basically had this concept that any developer could get their credit card out and do whatever they wanted. They could go and form a company if the boss wouldn't let them and go do it without regret, because they could always dial back down. They didn't have to have a planning meeting about buying a data center. They could just go ahead and get started. And now you have a combination of cloud hosting plus provisioning tools plus operating systems that update themselves, like Koros, for example. And that collectively is this lower layer of infrastructure. The next layer is the container service, and this is very, very important. This introduces a key distinction from the previous layer. The layer below Amazon, the evidence is clear. Amazon and people who compete with Amazon, like Google and Microsoft Azure and DigitalOcean, are there to give you an agile computing platform in the sense of hardware. But this layer goes further than that, because it replaces VMs with containers with the goal of making the overall startup time much less for any individual software asset, So that as you use more and more of these things and the times add up, you can still get work done quickly without having a kind of 30-minute pause while you wait for something to build and test and compile. So that means overall it's a subtle change, but it means that if you look at the evidence, that people are seeing much faster performance, much faster development cycles, much higher performance from the development teams. And it's portable. That's another key difference. One of the reasons this layer and the containers themselves are so appealing is that there's much more portability. An AMI from Amazon does not run yet on vSphere, I believe. Correct? So wouldn't it be great if we could just write for one thing? I mean, I know that can be a bit of a fantasy, but there's just much more portability with containers. You can run containers on Amazon, you can move them and run them on VMware, you can run them on Metal. The other thing that's really new with a container service, it's coming through with things like Docker Swarm, which is part of the overall Docker platform, and Kubernetes, which started at Google but is now moving to Foundation, and other technologies like that, people are trying to standardize the execution model for applications. That means taking two things and putting them together. One, a scheduler, also known as an orchestrator for containers, which understands what they're supposed to be doing, where they are, whether they're started or stopped, how many you've got running, that kind of thing. And core execution services is a bit like an operating system. Things like networks, coordination, storage, shared data, all this kind of stuff that you need for an app. And trying to make all of that common set of APIs. What that means is if you write on top of this layer, you get two things. You get something that's virtualized across automated infrastructures. You can move it anywhere. And something that has a standard set of management APIs, regardless of your application type. Which means that you can have a massive team all trained to know one thing only, and they can switch around between jobs. Which means that you can grow your team. You don't have people dedicated to individual tasks. It's much more like, in the platform, the microservices concept of breaking things up into smaller pieces and not having things being too big to fail. So, that's pretty cool, I think. And then this is the stuff that's been with us for a while. Now, what developers really, really like, in my experience, is to pick the tools that they know will do the job well and not be told by somebody else to use a different tool. So I was really impressed when I went to the DockerCon Amsterdam event last year, and I saw a gentleman from ING, who I believe is the CIO, saying that one of the things that they had done in introducing microservices was liberate developers to be more free to choose some of their own tools. So if the development team said, we want to use Mongo, not MySQL, be like, okay, fine. If you fail, it will be your fault. As opposed to, no, the central database provisioning team will not let you provision MongoDB. You'll have to go and you'll have to wait 3 years for that. And so developers hate this. And if you're in business of hiring in developers and you want to make them happy, remember if the right developer leaves, your business could be in trouble now. You've got to give them a bit more freedom and responsibility. You've got to make them accountable as well. And so this layer has been with us all along, and not all of it necessarily is suitable to running in the cloud or in cloud-native architectures, but a lot of it is. And so the point I'm really trying to make here is that it's very, very important that whatever stack you choose, whatever architecture you choose, you still leave open the possibility for individual teams to choose the tools they want to use. I'll come back to this point in a second. This brings us to the war of the platforms specifically. So what's at stake here? I'll just cover a few of the debates. I mentioned containers versus VMs and mixtures of these. So some companies like VMware, Joyent, and others have combined VM technology with container technology in interesting ways. Then you have the debate of unstructured PaaS versus structured PaaS, or unstructured platforms and structured platforms. And finally, another one that you see is opinionated versus unopinionated. And everyone's got an opinion. So let's talk about structured PaaS for a little bit. So what is that? That is basically somebody saying, I'm going to take a slice through the stack, and I'm going to make decisions about what's going to be in each of the layers for that slice. I'm going to put them all in a box. I'm going to sell you the box in one go. Who does this appeal to? Obviously, this appeals to vendors. It also appeals to big businesses which worry about technology and don't want to have too much noise across the team. When I said, I thought ING are pretty actually amazing, saying to people, use whatever technologies you like. Maybe it's not quite that extensive, but It's very brave, because if you're in a really big business, that could mean a lot of technologies, right? But the appeal to the buyer of the structured PaaS is somebody's going to make a few decisions, nail it all down for you, and just make sure they do a really good job of looking after that. The problem is, of course, it's a black box. If you're the customer, you can't change this thing, because the whole point of the value proposition is we'll do it for you, which means you've really got to have a high degree of confidence this is going to give you the value that you're looking for. That's why you'll see a lot of people talking about unstructured PaaS or unstructured platforms, which essentially means pick your own technologies at each layer, and they should just work. You should be able to use Kubernetes on top of automated infrastructure without caring what automated infrastructure you've got running. It could be on Amazon, it could be on Google, it could be in-house. As long as you've standardized on Kubernetes, the rest below it should be fine. So you can also have freedom of choice there, and then run whatever you like on top. So that's much more appealing to development teams who want to make their own decisions and don't want to be prevented from hacking the stack. And then you have the opinionated versus unopinionated debate. This arises because of Heroku, which is really the first platform as a service, and it created briefly an industry called PaaS, which I think people have slightly lost faith in. Opinionated PaaS says, we'll do it all for you, everything you need to build, run, and scale all in one magic black box. The problem is, I went to their site today, they've got these impressive looking numbers on here, but actually these are not impressive numbers. LinkedIn announced they're running Kafka for doing log processing and other things. They are doing now 1 trillion messages per day on LinkedIn's Kafka, okay? That's a lot more than that in one company. Who here thinks Heroku is making a lot of money and is a big business for Salesforce? Anyone? So why is it that this thing that gets a great deal of love from one section of the market, a certain type of developer, and don't get me wrong, I think it's a great platform, isn't dominating the world? Because people don't want to use someone else's opinion about an architecture for every type of application. It's as simple as that. So, back to the stack. Unopinionated. You can have an unopinionated PaaS. That's basically somebody doing the black box thing again, but saying, I'll look after the lower layers for you. I'll have my tectonic service from Kubernetes, from Koros, which is Kubernetes-based. I'll give you an enterprise edition you can run in-house, and I'll support a cloud version for you. You can just deal with me. Now, that has the appeal that you can have one throat to choke, which as a buyer, remember I said, can be very appealing. But it leaves the dev teams free to do whatever they like. But for this to work, you really do have to have an architecture that can support all these different application types. Now, Heroku, remember, is 12-factor PaaS. And not every architecture in the world is a 12-factor PaaS. That's why people are moving to these container-based systems, because they get freedom of choice around what architecture to use, whether it's 12-factor or big data or real-time streaming or something else. And you can recognize these types of applications, because if you ask the dev team to draw them on the whiteboard, instead of doing what they would have done 15 years ago and drawing something that looks like a cake, like that actually, they'll draw a big graph with arrows and boxes. That's showing that they have an opinion about their architecture, and it's unlikely to be identical to someone else's. So you've got to have a very rigorous execution model to support all these patterns. And that's why I'm excited about things like Kubernetes and Docker and so on, is because they really show promise to deliver the agility and automation, but without locking you into specific architecture types. And I think that's really fantastic. There we are, choosing Netflix again. So convenience, economics of convenience are important, but they do require choice. Choice is what you need, and choice is what developers have to be empowered with in order to deliver that for the business. So now let's look ahead a bit into the future. This is supposed to be the future, because it's dawn. I've borrowed a few slides here from our host, Mr. Cockcroft. Mentioned microservices earlier and mentioned different architecture patterns. This is one of Adrian's slides, kind of demarcating concerns in a microservices architecture. And I'm going to be talking a bit about the one on the right here, observability, because I think it's very important. Another slide from Adrian. You may have heard of this guy by now, famous American strategic thinker who started his career as a pilot, and then became one of these kind of RAND corporation types. And he came up with this kind of concept called OODA, Observe, Orient, Decide, Act, to represent what you need to be good at in order to compete with other people who are fighting for the same resource as you. Another slide from Adrian Promises, the last one that I've stolen from you, Adrian. But here's another example of the OODA concept applied to the innovation process itself. And as you can see, you go through the cycle again and again. That's the point. It never stops. And the idea, the central notion of OODA, that I think, it seems so obvious now, but when this guy came up with this, people thought it was really radical. Is the faster you can do it, if you can be doing it faster than your competitor, even a few percentage points on whatever metric you choose, you have a critical advantage that compounds over time until you win and they die. Which, if you work in a business that is competing with other people for a finite resource, e.g., customer money or something like that, is really important. So my proposal is that it's not just about process, but it's also about the platform. The platform itself has to embody these values. Observe, orient, decide, act. Orient, observe, decide, act. And what we're doing in Weaveworks is focusing on that, thinking about these sort of questions. Given that I'm running on a container service platform, therefore I could be running any architecture, there's all these things I really want to know as what's going on. I can't just take a single tool that's designed to work with an app server and a database and expect it to tell me the right things if I've got a microservices architecture or a big data app. But I want to know some basic questions. Is my app healthy? If I start it now and I leave it for 24 hours, is it still in the same state? And if something goes wrong, is it in the app or the platform or the containers or what? I mean, you've got all this new technology. How the hell are you going to know which bit's gone wrong where? So you need to figure all that out. And then you need to, of course, decide and act. So it's not just about learning, but also doing. Does it matter? Maybe it doesn't matter. How do I know? Compare it with the past. What should I do about it? And then who should do it? And then because all of this is so new, you also have to give people a way to get started. That's just a fact. So we call this connect, observe, and control your applications. Get started, orient and observe, decide and act. And we're giving you a bunch of tools, some of which are in 1.0 state, some of which are pre-1.0 state, to support that process. Nice quote from Mr. Cockcroft here, saying that we make it easy to do something. We made it so easy that as soon as we launched our software a year ago, everybody wanted to use it, which is really nice. And then in April, we started a second project, Scope, to go with WeaveNet, our network, which generates, no matter what your app is, no matter what your architecture is, a map of it, so that you can start the process of observing it, orienting yourself, and making decisions. And this is a living project that we, of course, invite people to get involved with. We did a release yesterday, even. That was 0.7. That was yesterday's release. We're starting to see a more sophisticated screen here. And finally, Run, which is our control point, right now very much focused on network operations like load balancing, but in the future on more things. So the use cases here are things like blue-green deployment. How do I do blue-green deployment independent of an architecture type? That's an interesting question. And you can use this stuff on ECS if you want to. That was something that Amazon were pimping quite recently. I'm very grateful to them for that. So that's what we do. Simplest way to connect, observe, and control your containers. Works with any app, no fuss, that's it. Thank you very much.